In this video, we are going to be differentiating inverse trigonometric functions. So for each inverse trig, we have a derivative that you are probably going to want to memorize. The ones that we're going to use most commonly are sine, cosine, and tangent, but all of them are shown at the top of the screen. Let's do some examples. We're just going to get started. So number one, I want the derivative of inverse sine of 2x or arcsine of 2x. Those mean the same thing. And we know that derivative of inverse sine is this 1 over rad 1 minus x squared. Now notice for our example, instead of an x, we have a 2x. So we're going to plug in. This is going to equal 1 over 1 minus, instead of an x, we have a 2x. And because I have a function 2x inside my arcsine, this is a composite, I need to use chain rule on the 2x. So I'm going to multiply by the derivative of 2x. Derivative of 2x is 2. If you need help with the chain rule, I will have my chain rule video linked in the description of this video. We want to simplify from here. We get 2 over the square root of 1 minus 2x squared is 4x squared. And there's your derivative. Let's do another one. Here I have 2 times the inverse tangent of 3x. Now this 2 out front, it's going to just be out front for my derivative. So I'm going to have a 2 times derivative of arctangent is 1 over 1 plus x squared. Notice that instead of an x, we have a 3x. So I have 1 over 1 plus 3x squared. Same thing as the previous example. Because I have a 3x inside my arctangent, I need to do chain rule for the 3x. So derivative of 3x is 3. Simplify. 2 times 3 is 6. All over 1 plus 3x squared is 9x squared. And there's my derivative. Next one, I have derivative of arccosine of e to the x. Arccosine is very similar to arcsine, I just have a negative. So I get negative 1 over the square root of 1 minus e to the x squared. And same as the previous problems, I need to chain rule the e to the x. Derivative of e to the x is e to the x. Simplify. We get negative e to the x over the square root of 1 minus e to the 2x. You're going to multiply these two exponents. I have a power to a power, so x times 2 is 2x. For example 4, we're going to be using the product rule. So I have x times my arctangent of the square root of x. So in the middle of my product rule, I am going to be taking the derivative of arctangent. So to start, I'm going to take the derivative of the first function. Derivative of x is 1. Leave arctangent of the square root of x. Plus, second term, I'm going to leave my x, but now take the derivative of arctangent. That's 1 over 1 plus rad x squared. Chain rule the rad x, I get 1/2 x to the negative 1/2. Let's simplify. My first term is arctangent of the square root of x. For the second term, I'm going to combine my x to the 1 and my x to the negative 1/2. That's going to be x to the 1/2. So that's the square root of x in a numerator. In the denominator, we have our 2 times 1 plus the square root of x squared is just x. So this is my answer. We've got a couple more. For number 5, I want you to notice that your outermost function is technically x squared. And then instead of x, we have arcsine of e to the 2x. So we're going to have to do some chain rule for this one. So my outermost function is the squared. So I'm going to bring down the 2, decrease your exponent. All the stuff in the middle stays the same. Then I need to chain rule my arcsine of e to the 2x. So that's going to be times 1 over the square root of 1 minus e to the 2x squared. Then I need to chain rule e to the 2x. Derivative of e to the 2x is e to the 2x. Then we need to chain rule the 2x. Derivative of 2x is 2. So lots of chain rule for this one. Let's simplify. And we get, let's see, we're going to do 2 times 2. So it's going to give me 4 e to the 2x times arcsine of e to the 2x. I'm going to make that my numerator. In my denominator, I'm going to have 1 minus e to the 4x under the radical. And that is my answer. Last one. I have 1/5 arccosine of sine of 3x. And I want to take the derivative of that. So let's do it. I'm going to have my 1/5 out front. Derivative of arccosine is -1 over the square root of 1 minus, I have sine of 3x squared. Chain rule the sine of 3x. Derivative of sine is cosine, so I have cosine of 3x. We also need to chain rule the 3x, so I'm multiplying by 3. Simplify from here, I'm going to have -3 cosine of 3x over 5 times the square root of 1 minus sine squared 3x. I can simplify from here. I'm going to keep my numerator, but I can use my Pythagorean identity. 1 minus sine squared of an argument is equal to cosine squared of that same argument. I'm going to continue my work up here. So I still have -3 cosine of 3x over 5, but now I'm square rooting cosine squared, so this is cosine of 3x. Your cosine of 3x's cancel, and we get -3/5. And that is our last example. So here were a few examples of taking derivatives of inverse trigonometric functions. Thank you for watching.